Okay, first of all, thank you for inviting me, and also thank you for the great hospitality, which I think is in the name of all the contributors. And it's always a big pleasure to be the last one, because you can skip almost all your slides. This is a great opportunity. Also, what I learned yesterday was, so I have prepared for myself a printout, because what Richie told me is that it's declining my memory, and I was a little bit optimistic when he had some results about fast walking, but then I saw there is no correlation. So I then asked the receptionist at the hotel to make me a printout. So in any case, I know what I'm talking. I hope so. Okay, so what I will be talking about today, first about the possible theoretical background. So why should individual alpha frequency be related to G? I mean, this would be so a theoretical introduction, very short, because almost everything, as I told, was said. And then two correlational studies I will present, actually correlations between individual alpha frequency and different constructs, psychological, like G, short-term memory, and working memory. I make this division, which will be maybe more clear when I come to this part of the paper or of the presentation. And then the last thing, what was also today already given, if we increase something, so if we do some intervention to the brain, can we see then any change? This is a very simplistic approach. So if I go now to this, you see this is an alpha written, eyes closed, and it's the most dominant written you can see. And of course, therefore, the idea was that you could use this alpha written as some kind of a biomarker for anything. So it could be for, let's say, a biomarker for depression, or maybe it could be a biomarker for intelligence. So we are in this relation. And so you have two elements in this. You have power, which is the number of neurons related to the amplitude, and you have frequency. So frequency was lately associated with what would we say, the white matter structure. So if this is correct, then we would actually expect that an increased individual alpha frequency should be related with intelligence. So why would this be? So there are some theoretical ideas. You have maybe the most influential theory at the moment, let's say, is the Young-Heyer parieto-frontal integration theory. But you have also, let's say, maybe the Duncan theory, which is more, it became 2010 parietal also involvement. Before it was totally frontal theory, but now it's multi-demand system theory, I mean, which is also parietal, but it's mainly frontal. Still, I mean, if you read the papers from 2010 and later on, you will see it's mostly frontal, and then parietal, it's just mentioned that there is there, but you don't know what the function should be. So this is the idea, and so I will refer to this theory. So if you look, this is the idea of the theory, and to combine all these elements, which are patches in the gray structure, that should relate to intelligence, the dark ones bilaterally, the more light ones unilaterally areas, and then you need something what connects this all together. So you need a white structure then that combines this, and so here maybe individual alpha frequency could be, let's say, could have a theoretical ground that it should be related to intelligence. So, and the second theory, which is, I would say, my favorite, is the Jensen idea that intelligence is actually the periodicity of neural oscillation. So it is a combination of these action potentials. So specific combination makes you IQ 130, a different makes you IQ 80, let's say. So simplistic, and this is an action potential. So the capacity is 1 millisecond. In 1 millisecond, and if you have many of these together, they can produce something, intelligence, let's say. So another part of research comes actually from the analysis of the integrity of white matter structure, how this integrity is related to intelligence. In general, you would say that the best, let's say, structural predictor of IQ, explaining the most amount of variance, is brain volume. So the bigger brain you have, if you have a very big brain, let's say, then you have more capacity. And it explains from 9 till 16% of variance. This is an estimation. And this was confirmed in several meta-analyses. The last one, I think, was the one by Piching from the Vienna University in 2015, I think. They publish something like that. But they have different numbers all over, so maybe if you take a Russian paper, you would have a higher correlation, and you would have also some gender or sex differences, which is also an interesting part, which will come into the play here. So here you have then this, we have done a very small analysis of 9 papers, including about 6,000 persons in this meta-analysis, especially for this presentation. And there is a positive all over, a very, let's say, stable positive correlation between white matter integrity measured by fractional anisotropy, which is a diffusion tensor imaging indicator. You can imagine, like for instance, if you have a drop of ink on your paper, and then this drop will move around because there is no resistance. But if you would have this old type of paper where there were small wood elements in it, then this would move in just one direction. So in the direction where there is the lowest resistance from the surrounding, and so it measures some kind of this. And all these measures are positive. So you have also other measures which are not so positive, so instance, which make a lot of differentiation, like for instance the brain convolution, then you have the cortex, the gray matter how thick it is. All these measures show some correlation, but they show also some big differences. For instance, when you are young or a child, then they are negative. When you come in some period of your greatest development, 20 years or something like that, then they are the highest, and then they drop again. So this is why also this should be an important aspect, which could, let's say alpha rhythm should be, or the individual alpha rhythm should be related to it. We must say that everybody of us has some unique characteristic of his or her alpha rhythm. So if we look now at the correlations, I must say that there are some correlations which show, let's say, some possibility that there could be a relation. You have a reduced individual alpha frequency in different clinical groups. So Alzheimer, dementia, and similar. But what is the problem is that you cannot use this as a biomarker. So even though they are lower statistically, they are not so low that you would say, okay, he has now, I don't know, individual alpha frequency 8 point something. This means he is schizophrenic. This one has no. This is not working. So it is just in the averages where you can get this. Then you have some research which was done before 1960 in relation to intelligence. And this, you have a very good review in 1964 by Vogel and Broverman, who did really everything what was up to that time. And I will just refer to one study from this area, because I don't know what type of machinery they were using at that time. So, you know, this was not the time of computers. This was the time of visual inspection and stuff like that. I know that because I was doing my first study, like visual inspecting and measuring the, the length, and similar to indicate alpha. So here you have it's a study by Mundy and Castle, which was actually published in Science in 1960. And they found a positive correlation of 0.34 between alpha. And they did this in a South African group of people. There was all men, one woman, I think they did, and they had a very, very, I would say, low IQ of 70 or something like that, average. So this is, I don't know how much this is, but it was published, and here you have the, so just for illustration, so you can see what we were doing when we were young. I mean, when I was young. So this is one thing. Then you have the studies which were done later, two of them which found no relation between intelligence. And then you have two studies where there were some relations. This is the Anokin and Vogel study, which was done, I think, in Germany on some military service officers, I think about 100 all male. And they found, you see, positive correlations with Raven's matrices and some other German-based intelligence tests, probably similar to the Wechsler. And then the lately study, which actually made me again interested in visual alpha frequency. So I said, okay, let's have a look if this is something what you could work on. And this is a study done by Grande and colleagues. And this study is actually based on, I don't know if you know, the Cogito project. This is a project run by, I think, Max Planck in Berlin. And they are doing training, IQ training program, and they showed that they could rise, I mean, this is the findings, they could rise IQ on a latent level of measurement. I have read this article. They didn't use an active control group, which maybe, but they have a big number of respondents, and this is an interesting study whatsoever. So they found in a analysis, structural analysis, correlation of 0.40, so I decided to see if this works, but mainly because you see here, you have this was published in Neuroimage, you have here their results, and they did, I think, 15 or something like that, 3 times, 2 times, yeah, something like that, and there were just five correlations which were actually significant, and if you would run any type of multiple comparison analysis, you would probably, all of these correlations would die, I think, insignificant. So therefore I was interested, let's have a look and let's do it something again. This would be the short introduction, and now I come to my first study. So the objective was, we had a big number, I mean big, okay. For our EEG data, we had a rather big number of individuals, and also what is impressive, we had a lot of males. You see, this is this is something. I'm also coming from a social science university. I mean, faculty, and then you have these big problems that you have just females all around you. But I have a good strategy, so I ask these girls if they have a boyfriend, and then I say, okay, we give you some course credit if you can convince your boyfriend to come and to to do some EEG. And so we have some of them who are very, I would say, persistent in this approach. So we got some males also in this. So. So this is some of the strategies. So we did, in the first round, we did a very simple, let's say, correlational study. We did a differentiation between location we collected anterior and posterior individual alpha frequency. This was done because what today Santernecchi already has told, because of the Connect-Home project, the default mode network, which connects parietal which connects actually the operculum and the medial frontal, lateral frontal areas with the posterior cingulata. So you have this frontal posterior relation, and we used, of course, because we had this opportunity, a moderator variable which is sex. This is, I must say, there is a lot of research showing differences between male and female brain on a structural level. Maybe the best known is the 100 grams, which we have more. Males, we have more brain, so we are more intelligent. 3.4 points. This is the estimation of, I think, Lin, yes, and Rushton and this group and Nieborg. I'm just fair and say everything I know. So this is one thing, but also you have some data where you can say, for instance, that speed of processing in females is much higher. They have wider eye fields. They are verbally PISA study. Maybe if you know this later, there are big differences in favor of females in verbal tests. We have also, male have a special, let's say, dominance in rotation, but only if you rotate 3D figures and you translate them into 2D. This is a study done by Neubauer, I think, some years ago. In Intelligence published, so far as I know. Okay, this was our first analysis, so we did these variables and why we did them. And then in the second one, we used a different, because you see, even Mundane Castle and all the others, they were thinking that actually the difference why sometimes individual alpha is related and sometimes it is not related with IQ is maybe because of the tests we use. So because we didn't have the real opportunity to use different tests, we just used these tests Wechslers. So we used the Johnson-Bouchard division between rotation, verbal, and focus diffusion second order factors. And when we correlated this in relation to male-female groups, this was the second objective. So in the first one, we didn't expect any differences. In the second one, we thought we could find maybe something. So the results were as predicted. There were no correlations significant with the whole sample when we did verbal performance and these elements, but also there were no correlations when we did it on the whole sample for the verbal and rotation and focus diffusion on the whole sample. But when we split this sample between males and females, we got significant rotation verbal factor in posterior individual alpha frequency related with individual alpha frequency. Yes, this correlation was positive even after correction. And in the frontal area, we got a diffusion factor in the anterior area with individual alpha frequencies. So this was in males. In females, so we would expect, because usually, as I told earlier, rotation verbal rotation is more male and verbal is more female, so we would expect a negative correlation. Then for the other part, it was negative, but it was not significant. And here you can have a look at the whole correlational stuff. So maybe some elements which are in my opinion important. It is that it seems from this data that in males it is important that you have fast processing, or let's say a higher level of individual alpha frequency positively relates to your ability to rotate elements. This is just in males. And this is a similar finding which was also reported by Dunst. This is a group in Graz, I think. They were doing it with diffusion tensor imaging, and they got also only in males this relation. Another aspect, so you have here, I think this is the correlation in the posterior area. And you got also a big scale study, also diffusion tensor imaging. Ingal Halker, I think is the name, 2014. They did about 900 or 950 individuals, all with this diffusion tensor, and they found a very big difference. So in males, you had a lot of intrahemispheric connectivity, so in just one hemisphere, and in females you have this interhemispheric, between hemispheres. And another aspect which was interesting, it was opposite when they looked at the cerebellum. So at the cerebellum the difference was opposite. So they did then this interpret, so what we psychologists always do, to find some concepts which would explain the brain, what we find in the brain. So they said that males are more perceptual, action-oriented, and females are more intuitive. Okay, this was their division based on this data. So another aspect which is also maybe interesting is that you have this difference exactly in the let's say domain where males are supposed to be better, and this goes along with the neural efficiency theory, where you have less is more by meaning of intelligence, but this is moderated by the difficulty of the task, by the area, which is frontal parietal again divided, and of course by sex. So females would display this when they are doing verbal tasks, and male would have this when they are doing tasks like we used here, let's say rotational tasks and similar. We also found a similar division for emotional intelligence. So females showed this superiority also in emotional intelligence tests, which is of course expected, and the difference was rather big, even more than here. Now, another maybe aspect is interesting. It's that you have for the rotational tasks you have this posterior area which is important, and for the focus diffusion, where you have a focused perception, is frontal, which would go along with the division that frontal areas are more involved in attentional processes. So this is the first study. So in the next study we tried, because there are a lot of results which show that working memory has some better correlation, so we did, and working memory is also one of the prominent candidates of prominent psychological constructs related to intelligence. So we did a second study, and here you have all the studies which we found are showing some positive correlation between working memory and between individual alpha frequency. I will come to this later on with a more detailed description. So maybe first some words about working memory. We heard this today a bit from a colleague from Poland, from Chuderski. Is this good pronunciation? Not so good. Okay. Not so good. So you see, a Slavic person can't know to pronounce them. Okay. This is really okay. But whatsoever. So we have different theories. We have different theories about what is the let's say the relation between working memory and intelligence. So you have this theory by Coven, and also by the Spanish group. You did research, I mean 2000, something like that, where you correlated the capacity of working memory with IQ, and you found that this is a main predictor of this sharing variance. But then you have another group, the Engle and Answorth, something like that, this direction group. Yeah. I will have now a drop of Rucho. So this will speed up my brain. And then the pronunciation will become perfect. And they think actually that it's not capacity, but it is attentional inhibition. So you inhibit the irrelevant elements, and this is what makes the difference. And actually, you will see here. This is above. You have a very common classical span test, and here you have these O spans, these more complex spans where you have to remember G, M, Q, H, but you have in between to do some tasks. So, and they think that then you put something in your primary memory, and then you put something in your secondary memory, and then how efficient you can actually find this these elements then later on in a retrieval process. This is the relation which is with intelligence. And the third one is Oberauer study. His idea is relational integration. This is what should be. And so you have here the test. So you see Tom Cruise lives in apartment 2A. Brad Pitt lives 2 floors above Tom Cruise in the apartment to the right. And then this vanishes, and then you get this where lives Tom Cruise, where lives Brad Pitt. So this is the test. But what is interesting with this test, I mean, so they find a correlation is just into this relation. But if you look at this test, so they become more and more like an IQ test. I mean, so you don't see anymore. If I would look at this, I would say this is an IQ test from some, I don't know whatsoever. Now, another aspect which should be mentioned is the neurocognitive perspective. So you have here 2 theories. A single slot theory, so you can see here the difference, and the continuous resource theory. So this single slot theory means that you have 3 slots where you can put in the information. And so if you are probed, for instance, then, oh, sorry, it goes back. Yes, if you're then probed, for instance, on this one, and this wasn't in your slot, so it's not there, then you just make a guess. But the continuous resource theory thinks that all the time you divide your resource among all the elements. So they are still all there, but there are some, as you can see, blurred. And so because of that, you have no possibility to find them out. But I would say, from a neurocognitive perspective at the moment, this second theory has more support. Because if you increase the number of elements, you get an increase in activity, but this wouldn't be predicted by this theory, because there is no difference whether you have 1 element, all the resources given to this element, you have 2 elements, all the resources divided by them too. So this is at the moment, but we never know, you know, it's always things can change. So from idea how this is done, it is actually done that the slots which are here resembled as cell assemblies, they produce synchrony results. So you have the reds in some synchrony, and this must be fast enough. So the higher the speed, the better it is. This must be fast enough so you don't get a decay. But this must be actually different from another slot, because you must then have another frequency. Because if you have all the same high frequencies, then you get a mass, and then you have no idea. So it's synchrony and asynchrony between these slots which make things to work, and therefore it's so capacity consuming that it is assumed that you have 3 to 4 slots what you can use. So the correlations, Clark study, this was done 2004, very big, and they found a backward digit span correlation just with the backward digit span correlation, and they found it with a regression analysis where the individual alpha frequency and age predicted the relation to backward. Then you have these 2 studies by Angelakis, and they found actually very puzzling results. So they found, for instance, that immediately before you do the memory task, immediately before you measure individual alpha frequency, and this correlates then with the output, with the number of remembered elements or rehearsed elements. And if it's done a day before, this data from this day to the previous one, then there is no correlation. This is very interesting. And they also found, but this was very small samples, 18, 19 persons. And also they found in another study that the relation is more in, let's say, during the tasks or individual alpha frequency after the task. So you get in this question whether we have different types of or different elements in this individual alpha frequency, so related to eyes closed or eyes open elements. And this is then the Klimer study done in 1993. So increased memory load led to a drop in the individual alpha frequency. This was their finding, and good performers had a lower drop than bad memory performers. So we did then our study with two objectives, explore the relation between individual alpha frequency and measures of verbal spatial working memory. We used the Corsi block for the spatial, and scope of attention. We used this array tasks you were also referring to in your paper. I don't know, I don't give you the name anymore, so the guy here sitting. And we also had an idea that maybe there is a difference between these two measured individual alpha frequencies. So we measured one in eyes open condition and the others in eyes closed condition. So this was the sample. They came 2 times to the lab, 2 consecutive days. And first day they did the EEG, eyes closed, forward, backward, Corsi tapping, and so on. We just measured the EEG for the individual alpha frequency. We didn't measure it during the task. And next day they came and they did no eyes closed, but we did just the visual area task while they were solving this task. And so this task looks like that. So maybe I just explain. You get for 400 milliseconds this pattern here, colored, and then you get a gray pattern for 1 second, and then you get a 1 second pattern where you see one of these 8 elements is encircled. And then you must just press a button, yes, no, whether it's identical in color to this one or it's not. So this is, according to Cohen, very scope of attention. This is the idea. And we used, for the analysis, we used this part as task related, because the Klimer study showed that here there is the greatest drop. And we used as a reference, we used here, you see in front here, which is not here, there. You have a time about 1,500 milliseconds where there is nothing going on. They just look there, and then we use -500 to -1,000 as a reference interval when they were eyes open, and we used a very sophisticated, newly developed methodology, MATLAB run, which was given to us as a, but you can get it now directly on the internet, so they're offering it. So this was the idea, and then we did the analysis. So we didn't find any correlations between individual alpha frequency and the 4 memory span tests. This was very disappointing, I must say, because I was very convinced that something will be found, given that this was such a big study done by the guy from the States. And why we didn't, the Clark study, why we didn't find any correlation? I mean, a possible explanation which comes up is that they found this relation as a age individual alpha frequency combination of factors. And so our sample was just 20 years old males and females, and their sample was 11 to 70 years. So there was an age-related decline probably because both things decline. Individual alpha frequency declines also as our memory span does. And so this is probably an explanation, because we didn't have enough variance to get this. But it's an explanation. Then the second finding was that we had a drop, as it's usually found when you do in individual alpha frequency during task performance, as opposed to the resting state with eyes open, of course, and the drop is related to the retrieval process when you try to find the if it's yes or no answer in this section. And this difference was more pronounced in why is this not showing? Oh. No, this is very funny. Okay, something is not here. You should see this graphical thing should appear now here, according to my memory. But okay, maybe my memory is not good. Women showed higher posterior and lower frontal individual alpha frequency than males, and this was not related to the area. So why we would expect anterior? All the differences were anterior, so frontal, because of the attentional component of this tasks, probably, I suppose. So. Now, when we look at the high performers, showed a lower drop in individual alpha frequencies. So you have here all the data, and if you look now, the whole sample showed a small negative correlation, but this was more pronounced. This is VACT is scope of attention, so how many you repeat, and RT is reaction time. This is how fast they press the button. And you can see that probably all the difference here goes for the males. So they had the greatest influence. The females had a more smaller difference. But what was interesting, the females showed a more fast answering to this task when they had the good performance. So this is an interesting finding, but it can be explained, as I told earlier, that females are, according to an earring study, they have faster processing, mental processing. They are much faster in this, in this Wechsler test, where you have to code these elements. You have these numbers, and then you must do it as fast as possible. You must put some signs in it. So they're better. They have wider visual fields. And we also found a lot of, in our studies where we did a lot of gender or sex differences, we found a lot of differences in relation to working memory. So these were the main finding. Also, what is of course interesting is that there were no correlations between this eyes open and the first day tasks of memory spans, and also not correlations from the eyes closed to this one. So there were no correlations. So we can suppose that we are dealing with different individual alpha frequencies, which are, some say it's arousal, a general level, and then some say that the open eyes is an activation of additional energy you use. But okay, this is a story. Okay, third study. I'm good in time. I can have another. Third study was the study where we used actually transcranial alternating stimulation. This is what Santernecki told. Only the Italian name I can do correctly. So we had this is a very small study, so 18 right-handed. We had 20, but usually these males, they are somehow a little bit more afraid about this brain stimulation, so they didn't show up next day. This is as it is. And we did sham verum. This means, sham means placebo, so you give them nothing on the same group, and the other is real stimulation. We did resting eyes closed EEG, Raven progressive matrices, and we used 2 parallel forms, which just 25 items. This was the idea, and here you have, okay, this figure is showing up, so you have all the data. So what we collected EEG when they came in the lab, then we gave them either sham or either verum stimulation. Then we again recorded EEG for 3 minutes. Then we did this Raven progressive test, which you have here below, with no stimulus 3 and 10,000. This is a difficult task because they were divided into easy and difficult. And then when the cross presented, they had to answer. And these were the locations. So we dorsolateral prefrontal cortex. This would be a proximity of that. But this is not such so that you would say, okay, as in TMS, where you have a very exact position. But okay, we found in some of our previous studies, we found that, for instance, if we are doing this stimulation here in front, we don't get so much differences here behind. This was but it is not like that you would say, aha, now here you have this 1 centimeter point and tap. It is going on. We used to make the brains faster, of course, we used the individual frequency, which was determined here, and we added 1 hertz, so we had a little bit faster, and so we did this was 10 or about 11 hertz, and this was the strength we used, range between 1,000 to 2,000. We didn't use a unique thing because, somebody complains that it is not good and that it has bad feelings, etc., etc. So we just ask everybody when he can still feel something or not, or so. And this is very differently. So afterwards, we also give a questionnaire to ask what they think was real or it was fake. So they don't know the difference, of course not. Soon, the objectives, we analyzed behavioral and event-related synchronization, desynchronization data, and some coherence data on this small sample. So it's not representative, of course not. But okay, it's an interesting study, we think, which could be run further on. So there were no differences. So they didn't know whether they got a sham or a verum stuff. Then there was a significant influence of transcranial alternating stimulation on individual frequency. This is very important. So we found a difference between pre and post-test only when there was the real stimulation. And here you can see the graph. So this was pre-stimulation, this was this prior, then in between here came the stimulation, and this was post, and this is in the verum. Here you have no, and also during task, this is eyes open, of course, there was not a significant difference anymore in the individual alpha frequency. It just dropped, and there were no relations significant with performance or anything else. So this was the proof that we actually did increase a bit of the speed, and it was on average 1/4 of a hertz, so 0.25 hertz. This was what we got. Now we then run a general linear model, and we found sex transcranial interaction in males. So this is very disappointing. In males, it decreased performance, and in females, it increased slightly the performance. So you will see the data shortly. So you can see this is the male sample up there. So when they did this verum stuff, they performed lower, and the females performed slightly higher. But this difference is when you do it in a t-test or something like that, they are not significant. So just the interaction effect is significant. So the increase is significant in relation to sex. So why is this so? Okay, again, some interpretations. Maybe Deary would say cheap talk. Okay, but let's have it. I mean, we are used to do that. So the possibility is, of course, because if you look at the Raven progressive, there is some evidence also coming from the Spanish group. So this is here. I don't know which university, but I think it's Spanish group from Madrid. That collaboration. Okay, so it's okay. That there is some special ability needed to do the ravens, and so therefore maybe it could be that females have a let's say more difficulties. So this could be one of the elements that this was happened. Another aspect is because we did a lot of training studies to increase special ability in females, and we actually succeeded in this, that males are doing all their tasks, when you look at the EEG, by parietal activity. Females frontal. So it is a top-down procedure, it suggested, and a bottom-up for males. And so maybe because we targeted the wrong areas in males, we got a decrease and we got an increase in females, but this cannot be actually tested at the moment. So we would need to run a different study to increase this in the parietal zones and see whether there is a better influence on male performance. We did this, but not with individual alpha or +1 alpha stimulation, but with theta stimulation. I think we did something, and the guys in Graz did something. They did an fMRI study with the similar tasks and similar distribution of electrodes to increase. And I think this was presented in Singapore last year, where there was this conference on brain stimulation, the first one, I think, the results. So they got the same increase, but there really was an influence on the even progressive performance on both sexes. So this is maybe a special aspect we had. So we later did also an analysis of the EEG data in the upper alpha band. So we got what is expected, because these are very difficult tasks to do it in such a short time period for the respondents. And we got actually an increase in the upper alpha band. So in the band where we actually stimulated, because the upper alpha band, the lower bound of the upper alpha band is actually individual alpha frequency. So we got this increase here. You have here this differences. Red means more activity. And we did also a coherence analysis, and we got a dissociation. So we didn't got an increase in coherence, but we got a right temporal dissociation. So you have here this dissociation, which was significant in the upper alpha and in the theta band. So you have this hub, which corresponds let's say, EEG is not a measure of precision with spatial resolution, but okay, it corresponds to something what we could call a default mode of working with frontal parietal relations. So this is what we found. It's similar to some training studies done, I think, by Takeuchi and by Oberauer and Boston, I think, which they trained, and then they found differences in the networks. But this was done with fMRI and the Oberauer study was done with a much more dense EEG recording. So this, in general, is what is my presentation about. I didn't include any perspective to the future, and I would say why. Because I do remember. I mean, this is what I think about these predictions. When I was maybe a teenager, Neil Armstrong landed on the moon. This is 1969. Most of you were not born, yeah? So, and at that time, you got then, maybe so in the next year, you got these predictions. So it was said, for instance, in 80, we will have a moon base with, I don't know what, so we will do mining up there and everything. And till 2000, I think 2000 was Saturn. Mars was something in between. And if I would say, at that time, say, okay, guys, in 2016, we are not able to come to the moon anymore. Everybody would laugh at me. So thank you very much for